Hi all, this is Claudio from SPTFA.com, sustaining a live stream about CFD simulations in ANSYS Discovery. So let me firstly share my screen. A quick reminder about the website that I manage, SPTFA.com. And let's see where we get the geometry from. GrabCAD.com, and here most downloaded, let's say. Let's search for something like fighter jet. So we're looking for something that is very not so detailed, very reliable, precise, but not so detailed. All right, so we don't want the rockets and like here nozzles and look, something more simple, let's say. Can we take this? Let's see. And then even this one would be interesting. But we will see once you open it in Space Clay. This I have analyzed recently, F117. This looks nice. All right, so let's look here. I like the fact that it is Parasolid. Download. Like. And F18. This looks very nice. Like F22. Gears up. All right. Download like, and maybe we should kind of stop somewhere. Like, and let's see if we are so. Let me open Space Clay. And here we are evaluating what we just downloaded, yes? So the software that we are using today is ANSYS Discovery, which I can say is the easiest and the quickest software for lots of FEA simulations, also CFD and thermal simulations. You will see in just a few minutes how quick it is. Of course, it is possible to run, according to my knowledge, only if you have NVIDIA video card. Yeah, so I think RTX and GTX range, something like this. Let's see if Space Clay opened. Yes. We are going to drag and drop these models. We have 4 until now, and I'll give a quick glance on each model to check which one is more suitable and without requiring much effort. We're addressing beginners, and I want to attract new engineers, students, and PhD people towards a very quick and user-friendly package as ANSYS has in its entire suite of products. So let's see. Okay, this one I downloaded. Let's see if something catches my eyes. A51 Griffin. I'm not interested in UAV right now. Sukhoi. Come on. Can't I open it, the 3D? This is French. And this is Russian again. We usually stay clear from IGS because mainly they are surfaces and they need lots of healing, let's say. So a small kind of mishap here. I put all of them in a single window, let's say. All right, so drag and drop this one, drag and drop this one. We don't want all the 3D models bundled up in only one session, in one file. All right, so let's see also this F18. This seems kind of too much because it has lots of separate surfaces. This is promising. Only the problem is that it only has one solid body. Everything is surface. So let's forget about the F18. This looks very nice, and I'm interested in solids. This is a solid. Why do we have so many, I don't know, protrusions, decals? It's too detailed for what we are going to need. We're aiming to have a very stress-free model. I'm looking for small parts, but I think the person that modeled this, it did such a nice job that it kind of complicated the model. So if the air comes here, it gets stopped. For example, what is this? Can we delete? Yes. Let's attempt to make a section view. Design plane. I selected three points. It needs a rotation. Let's see it from above. Something like this. Yeah. Now let's go towards the section mode. It is pretty interesting. Too many details. Look at the buttons and the joystick, and yeah. Let's see if I can get inside here. For example, can I hide this? Not so much. At least can I make it transparent? Yes. And cables. All right, so what is this? This is the main body, and this is the right wing, left wing, a detail from the left to rear wing, okay. Aileron, I think it's called, another aileron or tail, nose, another aileron, probably from the right side, yes, and small tail. So where are where is the joystick and everything? It's built in there. Delete empty components. These are two small details which I would like to disappear regarding the complexity of the 3D model. Can I delete this small channel? There is also a hole here. Not anymore. Let's also delete the hole here, and this small groove or whatever is this. All right. How do I get inside here? Yes. Let's also remove the joystick. We have some, whatever is this. There were some plates or something. Another joystick. Maybe this is the parking brake. I don't know what is this lever. Can we, or can I delete it? Let's see. Yes. What about these buttons from here? The main screen. So we're going to simulate what occurs, what happens outside. This is what we don't need, these details from the inside. Goodbye cables or conduits, pipes, whatever. Double click, delete. Yes, so it goes very smooth. And can I delete this LCD panel? Yes. Also, what have we more inside here? Let's delete this thing. Then maybe from here, something like this. So this person has put a lot of effort into this model. A lot of effort. All right, so can I delete this thing? We don't need to exaggerate with the simplification, otherwise maybe we will get errors. So these are, maybe they are called pitot-Prandtl tubes to measure pressures or variations in pressure, something like, if I remember from when I was a student. All right. Also, what have we here? Something like this. No, it doesn't work. So we have also this option. The option is called clicking the specific part. Right-click, select depression, maybe. No, or maybe protrusion. Let's see. Select protrusion. Delete. No. All right, you know what? I'm pretty satisfied with what I found. Let's save this. It was called F22. F22 Fighter V1. All right. So we have everything. By now it's solid. What is this, for example? This small thing. We will delete this. And this, another small thing. Let's delete it. Oh my God, so many details. All right. Can I delete this? Oh, both of them? Oh, yes. I perfectly agree. What is this? What about this? Come on, get it out. Get it out. No? All right. Another detail here. Another triangle here. Come on. Can I delete all of these in one single go? Yes. So again, what have we here? All right. We have something here. Ooh, see the engines. Can I delete this? Yes. What about here? Yes. I would like to move the plane, this plane, to move it in order to see inside the jet engine here, for example. Yes, why not? What I don't like too much is that the air gets stuck here in this cavity. I would have liked to fuel to enter the jet engines, but we don't have such a detail. So let's save, and I will check for messages if there are. No message. Very good. All right, so what is with this? It's no more. All right. And the question that we have now is if we can join everything. So combine, and we're going to select all bodies from the right to the left, and hopefully they will merge in one part, hopefully. Did they? Or not? No, not so much. They do seem kind of separate. For example, this thing is pretty far away. Let's stick to this assembly. And before moving towards CFD, oh my God, this is so nice. Oh, but everything is surface. For example, if we are going to repair and missing faces. Oh, it's kind of too much. Let's go for stitch, 3 stitchable edges. Complete. All right, and now if we're going again on the missing edges, missing faces, what will happen? We would like for this model to become made of solid parts, either one or multiple. If there are multiple solid parts, we will attempt to join them, fuse them in one big part. It could have been better. Ooh, what is this? This is this thing. And this is this thing. All right. I don't care about these two so much. Can I instead heal only this? I like this profile very much. Can I heal this? Let's see. Stitch again. 1 stitchable edge. All right. Done. Here I think we've gotten in some troubles here. Missing faces. No. I avoid using the gaps command because it usually stops the software. But you know, why not? Missing faces, all right. Stitch again. No stitchable gaps. Missing faces, no. All right, so what will occur if I will kind of delete what I have here? Can I delete these faces? Yeah, too complicated. So I advise you to open ANSYS Discovery, and here we will drag and drop this model that I saved on desktop, this one. We will drag and drop it in ANSYS Discovery. F22 Fighter Viewer. So we have 2 options here to open as a singular geometry or insert in an existing geometry, in an existing assembly, all right? We're going for open. Now, what I didn't check is I didn't check the size to see if it's kind of realistic or not. Come on. Show me. Yes. Let's measure the distance between 2 vertices. Did we have something? Another code while loading the file, would you like to load only the geometry? Yes, only the geometry. I said I will measure. I will click a vertex from here and the vertex from here. And the distance is 18 meters, so it's fine by me. I don't know the exact length of the F22, but 18 meters, it's fine by me. The default the main body is shell. Why is it shell? Because here it's not shell at all. It shouldn't be shell, and everything is collapsed, is expanded. Right click, locate in structure tree. Look here, it's It's solid. All right, so we're here. Can I attempt a healing? We have here repair. And what should we do? Search for missing faces. Oh my god. How many are they? Allow multiple faces, alright. And check. Huh? That's all? Oh, difference. Patch, come on, patch. No, it doesn't do so much or nothing at all. No, let's say don't know. So back to space claim. We're forgetting about this. There was another 3D model that I didn't insert, or maybe two of them. So the purpose is to kind of solidify them and to have right bodies, let's say. So we have a message, messages. Can I install this software on my LAPI? Hoping I understand English. Why not? Yes. Some problems, only one. Solid. Can I go for missing faces? Oh no, please, no. In here. This, oh, it looks so nice. What have we here? I'm looking for surface bodies. Do I need this thing? Oh, it's kind of important. An engine without a plane without an engine. It makes no sense. Look here. So the air travels through here and it goes through the engine. Oh my god, it's so nice. What do I do with this pipe? Do I care about this pipe? Sincerely, I don't care. Do I care about this pipe, which is kind of randomly inserted there? Oh, let's leave the engine inside. And is this an overkill or not? Do I need this or not? Let's split body. Ah, it's a different part, all right. What is this? Locate in structure tree. What is this? Come on. If I delete this, let's first save this model. It looks promising. F35, yes. I can delete this model. $35. All right. What do I do with these faces? Can I? I can select them. Can I just forget about them? Let's see if discovery is forgiving. Open. What is the purpose of this analysis, may I ask? To see the streamlines, also pressure and velocity that will envelop the airplane model. Also to see the quickest software in CFD, and yes, to attract beginners in such simulations. If I right-click, can I delete empty components? Yes. All right, let's not complicate it. Explore. I will do a very quick pre-check, let's say. Fidelity towards the middle. This is the so-called, let's say, the meshing side. The meshing side of the software. All right, so we're going to external flow. We can go and choose other domains, let's say structure or CFD or thermal, even electromagnetics. Yes, but the easiest way is to go here, external flow. By default, it will make a cabinet or an enclosure, and it will ask for the, let's say, for the inlet in this enclosure, yes? So the air will come from this side. It says now select the ground plane for the enclosure, all right? We need to select this side, all right? I think the simulation already started, and we have something like a default value here. Let's say 350, all right? 350 meters per second multiplied with 3.6 is around, who knows? This speed in kilometers per hour, yes? 1260 kilometers per hour, all right. The fluid is gas by default, air, ground plane, extends, non-slip wall, all right. So let's see if it works, all right? It kindly asks for a save on the desktop. Yes, why not? Save. Let's quickly see what will happen if I click solve. So by default, there is an inlet and an outlet. I selected the inlet, which also gives the air direction. And the outlet is on the opposite side, defined by zero pressure. It attempts to solve it. There is a slight white segment that is moving along the hexagon. There is a message, temperature dependent are not applicable for this type of simulation. We don't care about this warning because now we're going for only for velocity, streamline pressure. We don't care about temperature at this moment. So it takes some time to solve. This is, let's say, the quickest way and the easiest software, I would say. Let's click on some of the, maybe go here for you to see. Let me check if you see. Oh, all right. I want to check the limit. So you see until here. So if I go here, all right, so the software should be something like here. So did you see so quickly? All right, let's go firstly for particles, and you can see how there are different regions with different velocities. This is the velocity here, all right? This is the magnitude. If you want the velocity only about an exact axis, you have, for example, z-axis. Yeah, and it will be with the maximum, let's say, on the negative side of the z-axis, because the z-axis has the negative towards the right, towards the airflow. So if it were after me, I would have resized the cabinet, the enclosure, and I think I will do this. At this moment, let's also look at the section plane to see where is assigned here. Let's move it. Hopefully we can. Do we have something to grab it by? We have here a coordinate system at this point, yes. So look here. When we're on the cut plane, the first option, then we have a small sphere, a blue sphere, and we can drag and drop, rotate whatever we want. Yes, let's drag it. And you see the section. All right, this is kind of let's move it a little. Come on. So because here is kind of limited and the ground is exactly touching the airplane, I will also show how to move the ground, yes? To let bigger offset, more slack here below the airplane. I will show how to move the ground in a few minutes. So it looks very nice. We're watching now the velocity about the z-axis. Let's go for the magnitude, yeah. If we want to rotate the section plane, this is how it looks like. Just look for the small blue sphere, yes? And when you click it, you can adjust these arrows. For example, if I want to see what happens on the wing side, let's say. Yes, I will click something like here, and hopefully I will grab the correct axis. Come on, please do it. Yeah, something like this. Look here, what happens on the wings location. So this is the velocity. Can we have, for example, static pressure? Yes. So static pressure. Of course, some vortices begin to appear. And also at this speed, we can talk about the sonic boom, but yes, I don't know if it's visible at this moment. There is also the option for the total pressure. Let's rotate the plane, something like this, and move it here to see the total pressure in this direction. Look here. You click these arrows or the small spheres from the global coordinate system, and you can see the total pressure, yes? Or even vortices lambda, yes? The place where the vortices will appear. So remember to drag the blue sphere. Look here, yes? Vortices in the near the wings, yes? Due to the high velocity of the air. So this was the section view, let's say. Here we have the particles. If you don't see, maybe let's do it like here. All right, you have particles. Remember to kind of edit and experiment. For example, the range. You can move this cursor. It's not very spectacular because there are less vortices, let's say. This is kind of much, let's say. I would like to show you the origin of this this view here. And we also have the size of the small spheres. So, and also we have the animation speed, something like this. Emitter control. If you click emitter control, you can kind of customize the inlet direction and size. Look here, I clicked on the circle, and we can kind of edit it. It's very useful for visualization purposes. Also remember, you can click the small sphere and move the emitter. We're not interested on what's happening above, we're interested, for example, on what's happening in front and below. Yes, and we have isolated only this because it was overwhelming to have the entire enclosure or cabinet filled with these spheres or the upcoming streamlines that will appear, right? So this is why this is very helpful. Let's resize this sphere, for example. We can go here and maybe move this circle. We're interested only in this, for example, for this domain, yes? it's overwhelming and cluttering, confusing to have so much space filled with spheres. All right, we played with this one. Let's see if we have streamlines. I'm curious. Yes, we have streamlines, but as said before, it's kind of too much. It's very hard to understand what occurs here. So set the emitter control. Let's edit it. Yeah, we're interested in what will occur here, where the airplane is moving. All right, so we can change the thickness, but it will impede the visualization if it's too populated with streamlines. Then we can maybe increase or decrease streamlines, something like this. Yeah, add emitter. Let's see. We can have two emitters. So this one, let's make it also smaller. And maybe move it all right. I hit undo because I would like to move it something like this. I'd like to have an emitter here on the right side and an emitter here on the left side, if possible. Is it possible? Let's see. Three emitters now. Yeah. Let's undo, Control Z. I will undo again. And again. And again. Because we have such a big emitter, then it displays what's happening inside the enclosure, let's say, and it's not, let's say, relevant to our simulation. What have we here? Default emitter. All right. Finally. So, isosurface, the small clouds. Yes. Let's set a value 1. What is 1? There, and 0.1 meters per second. It filters according to what it has in the legend. 10. Do we have 10? No, because the maximum is 2. 0.1, 0.2. Yeah. Do we have static pressure? Yes, with varying values. It keeps animating the simulation. Total pressure. Yeah, just feel free to modify what you see. So it's not so revealing for us at this moment. Contours. Here, this is helpful. Yeah, to see what's inside is helpful, mainly if we select bodies, all bodies. And in principle, we should see what's happening here. The enclosure somehow I lost some properties of the enclosure, so I need to remake it, let's say. It shouldn't be only this one. Ah, there is no flow outlet, yeah. I felt that the enclosure is not good anymore. Let's define an outlet. Fluid flow. And we would like to select here outlet. And I will click here. 0 is good. And all right. So now we should have the proper streamlines and everything. I hit undo too much. I think I also lost the ground because I cannot see it anymore. Can I insert the ground? Just asking, is it possible? Right click, include, hide, select, no. Do I have a ground here? No. All right, I can at any time remake the external flow. Let's see, for example, if we have we can change yes to velocity and something else. It's this simulation needs to be remade. Let's see a little these errors. Yeah, they are not very revealing. Can we go and delete these? Yes. Why I wanted to do this? Because I would like to resize the enclosure, let's say. Also delete the enclosure. I would like to take it from scratch. So, external flow. At this moment, you know what? Let's make here this one to be the inlet, because I promised more directions. And here it says select the ground plane for the enclosure. It automatically goes, and it makes the ground to touch to the airplane. And what I would like to do is resize this enclosure. I don't think we can do it here, but if we go in model, here, right click, let's see if we can edit it. Not like this, only if I select this face, we have a simple move command. And we can see what happens more under the airplane, all right? And, for example, above, it's too much space, yeah? It's a waste of mesh, let's say. Here, we don't care too much, so let's also resize it. Also here. Something like this. How much space do we leave here? It's kind of too much for the outlet. Yes, so the air comes from the right, all right? So now we go again towards Explore, and here 200 meters per second. Let's save. We click solve here, and the solution the software starts solving. All right, look here. In an instant, it defaults to the vectors, but we're more interested, for example, in these ones. Look here. If you want to resize this plane, let's see how we can resize it. Click here on the small sphere and maybe drag. Yes, we have the entire periphery of the cabinet, let's say. If you want to move the plane, just grab the arrow. Look here. It shows so nicely what happens also below the airplane. Yeah, because we moved the enclosure limit, the ground. We moved the ground even lower than it was by default. Yeah. So another one would be maybe this one, which looks very nice. Do we have kilometers per hour here? Let's see. Yes, we have. So we have almost 1,000 kilometers per hour. Let's see what happens transversely. Something like this. Let's see, the vortices should be nice. Yeah, look here. We drag the arrow, and we can see the vortices when the air comes from the right. All right. So it's so nice to see them. Let's go back and also, why not these small spheres? Velocity. I should be able to somehow rotate this, maybe. Maybe, but not today. We should have had a rotation option. Let's see if I can, if we have the reset to the default. Yes, this one. All right. So we click the big circles, the big circle, and we only encompass the useful part of the fluid that envelops the airplane. Yeah, even more like here. All right. We need to be able to edit everything. We need to master the software. All right. It shouldn't be anything at random. Animation speed, and it looks very, very nice. Do we have pressure? Yes, we have also pressure. And the vortices, lambda with very few spheres, only where the vortices appear. Let's see if we have any message from the audience. What is the purpose? Oh, answer this question. Streamlines. We need to reset to the default emitter in order to be here, and we're making it to encompass only the airplane. Oh my god, they look so nice. Something like this, and maybe, yeah, look here how nice they look. Can we make more? Yes. The thickness. Look here, it looks so nice. seen from this direction, it looks so nice. All right, so feel free to adjust whatever you want. So we can edit everything. So this was the surface. Now we're on the contour side. And I don't know if you can see this. Let's go for all faces here. You can begin to see what's happening inside. Can I hide the enclosure? Look here, hide, yes? But it's not so useful to hide it. I was wondering if we can make a section plane. Here is the section plane, cut plane, yes? Here is a cut plane. What I would like to do is to locate how I can maybe edit this cut plane. I see a point here. And we can move it, yes? Something like this. Follow the small arrow. There will be a small arrow. This one, yes? So you need to hover in order to catch this section plane. Something like this. This is the velocity. Let's make this section plane, this one, and drag it here. Something like this. Also, because we're on this direction, this would be interesting to see. I didn't want to do this. Here, I would like to see the velocity around the wings here. Also pressure, and we can move and see whatever we would like. Vortices, lambda. I think there are very few. This is why they're not shown clearly. And let's move towards these arrows, or kind of streams, let's say. Do we have an emitter here? I don't see an emitter. Tail length, all right, and count. It's too much. Thickness. All right, so fill in the leg, right? So let's save. Let's see if there is a question. No. And yes. This is this is an overview of a very simple CFD to flying aircraft. So yeah, that's all from my side, and I will hear you next time. The files used in the simulation, you can mail us from the contact page on explicit.com. We will make available for you for a few coffees. So good luck, and be curious. Be curious, experiment, and try new things, and you'll quickly become attracted, because this suite of software, ANSYS, is very beginner friendly and user friendly, and you can learn so much from it. It has a very lean learning curve. It's not steep. It's very easy to acquire quick knowledge in this software. That's all from my side. Thank you.